Okay, we're looking at the angle between two vectors. This is for IBSL and for HL. For HL, you really need to know how to do this. For SL, it's not quite so important, but it provides very good background information. So I've got two vectors. I've got OA and OB, and I've got OA is given as x1, y1, so I've got components there, which is the x1, y1, and the B has got x2, y2. And I've also now worked out the A to B. Now A to B is B minus A, so it's x2 minus x1, that's where I've got this from, and y2 minus y1, which is where I've got this one from. So now I've got all three vectors. I'm now going to use the cosine rule. So there are my three vectors at the top there. Now I'm going to use my cosine rule here for each vector. Now I've actually already got OA and OB, and I've got AB, and all I'm going to have to do is square or find the magnitude. Normally to find the magnitude, I square that one and add that one on squared and square root it, but as I'm also squaring it, this is what's going to happen. I'm going to get OA squared, and I'm going to get OB squared like that. Now I'm also going to square AB to get this, and I'm now going to look at that AB squared, and I'm going to expand it. So maybe you need to explain a little bit what I've got there. I've done x2 minus x1, and I've squared it. So this gives x2 squared minus x2 times x1, and then x1 times x2. So I've got minus 2 of those. Minus x1 times minus x1 gives me this. So this bit here, that's this expansion here. And it's exactly the same for the y's, except obviously we've got all the y values in here. So now I've got all of these values here, like that. So let's just explain now. I've got this here, I've got OB here, and I've got this big expression for AB. So what I'm going to do now, get back to where we were. So what I'm going to do now is put that huge thing into this equation. So OA, here's OA, OB here, and then we're taking away, and everything here is in a bracket, and that's that big expression up here. And I've done nothing with the bottom whatsoever. So what do I get here? Well, I've got an x1 squared here, and I've got an x1 squared here, but it's negative positive. So this one is going to cancel off with this one, like that. Similarly, the y1 squared and the y1 squared inside the bracket, and if you can't see where those are, that's this one minus this one here. That's also going to cancel out. And the x2 squared with the x2 squared inside the big bracket cancels out, and the y2 squared with the y2 squared inside. So once I've cancelled all that out, what am I left with? Minus just this expression here and this expression here. And I've done nothing with the bottom. So let's go on to the next slide, and I'm going to simplify all of that. And that's what I've got. Now, of course, these two minuses, the minus is going to make a plus, the minus is going to make a plus, and these twos will also cancel out. So it will give me this. The twos will cancel out, and it gives me this. Now at this point, what's x1, x2 times x1, y1, y2? Well, we have to go back and think about the dot product, how we multiply two vectors together. So if I've got that, if I times this by this and then add this times this, it's the dot product between two vectors, which I write as this. So I'm going to replace this top line here with this. The dot product can go in there, and I'm almost finished. What I've actually got is this. So basically what I'm saying here is if you can just do the dot product of your two vectors and divide it by the magnitude of the first vector and the magnitude of the second vector, you're there, you've done it. And this is the general equation, and on the formula sheet the general equation is this one here, where u and v are the two vectors. I know that's a very complicated slide to follow. You might want to watch it again, but this is how we arrive at the formula for the cosine between two vectors.